Alright, so this is the introduction lesson to the polynomials unit in Math 9. So this lesson is intended for students who've never encountered polynomials before, and we're going to learn quite a few terms and learn how to represent polynomials in different ways and how we might use them to solve some problems. Okay, so let's talk about the word polynomial first. The word polynomial, oops, sorry, I used a pen instead of a highlighter. The word polynomial comes from the Greek word poly, which means many, and then nomial, which means numbers. We use polynomials to solve many problems involving algebra. Let me give you some, excuse me, some examples of polynomials. So polynomials involve numbers, but also variables, which are just symbols that represent unknown values. So an example would be 3. A number is technically a polynomial, but you could also have something more complex, like 2x minus 7, or you could have something like 5x squared plus 4x. You could have fractions as well, so like half, and you can have other symbols to represent your variables, like other letters. Something like this would work. And finally, you can also have negative numbers, so like negative 3k squared. You could have more than one variable in your expressions. These are all polynomials. Let's talk about like the different parts of each polynomial. They all have different names to describe them. So these polynomials here all have different numbers of terms. So the terms are separated by addition or subtraction. So like this polynomial here has 1 term. This polynomial has 2 terms. 2x is 1 term, and then 7, negative 7. This one has 2 terms. This one has 2 terms. And this one has 3 terms. You could have as many terms as you like. You could even have 100 terms, although that would not be very common. Most commonly in this unit, you're going to see polynomials up to like maybe 3 or 4 terms. Okay, some other things. Looking in green here, the coefficient. So when you have a variable, the number that is multiplied to it, if there is one, is called the coefficient. So let's add a pen here. I'm just going to put a highlighter in. The coefficient here of the x variable would be 2. This coefficient is 5. This coefficient is 4. This coefficient is 1/2. This coefficient is negative 3. This coefficient is 6. So the coefficient is the number that is multiplied to whatever variable you have in your polynomial. Next, we have our variables, which I've been talking about this whole time. So this polynomial, the first one here, doesn't have any variables. This one has the variable x. This one has variable x. This one has the variable y. This one has 2 variables, k and j. And those variables could have exponents on them or not. And then finally, if you have any numbers that are alone without and not attached to any variable, they are called the constant terms. So the constant terms that we have in our polynomials here are 10, negative 4, negative 7, and 3. So those are all important, that's all the vocabulary you need to know about sort of labeling and describing the different parts of a polynomial. Let's practice now, see if you understand. Or actually, let's fill out this little table. So a term is a single number, variable, or coefficient multiplied with a variable. The coefficient is the number that's multiplied to the variable. A variable is a symbol that represents a number that is unknown or changing, usually a letter. Represents an unknown value. Represents then a constant is a term with no variable at all, so just a number. Okay. We also have words to describe the different polynomials that have certain numbers of terms. So we have these prefixes in front, mono, bi, tri, and then poly just means many. So a monomial would have one term. So examples in our list above, I'll just zoom out a little bit so we can see the list and what I'm talking about here. Just adjust. So the example with only one term above there would be the 3. That only has one term. Or you could have a variable attached as well. A binomial, bi means 2, so it'd be 2-term polynomial. So we had a couple there with 2 terms. We had 2x minus 7, we had 5x squared plus 4x, and we also had, I can't fit it here, but half y squared minus 4. Those all have 2 terms. And then trinomial, the prefix tri means 3. Think of the word tricycle, right? That has 3 wheels. And so the example I gave above there that has 3 terms was this one. And then poly just means many, or any number of terms. Can be any. It's just the general description of any polynomial. Okay. And finally, another important thing is the degree. This is the largest exponent. The largest, I'll say, sum of exponents on any one term. Let me give you some examples. So from that list above, 5x squared plus 4x, the largest exponent we had here was 2. And so the degree would be 2. If you have another example here, 2x minus 7, there are no exponents, but technically there is one. It is here. We just don't write it. That x technically does have a exponent of 1, so the degree is 1. And then if you have more than one letter in one term, so like let's say I had 3x squared times y cubed all in one term, then you would add those exponents together. So the degree here would be 5. Okay, great. So that's a lot of key terms thrown at you there. Let's practice using all of those. Okay, so I have some different polynomials on the left, and then we're going to just fill out this table with all the information using all of those words we just learned. So if you feel pretty confident, you could pause the video here and try this on your own and then come back and check. Okay, let's talk about the variable first. I used blue before to describe the variables. So the variable in this equation, or in this polynomial, is x. It's not an equation, it's a polynomial or an expression. The constant term, I used pink before. That's -7. It's the number that's by itself, if there is one. The number of terms here, there are 2 separated by that subtraction. So there are 2 terms. It is a binomial because there's 2 terms. And the degree, there is an exponent of 1, even though it's not written there, so it is degree 1. All right, next example. The variable here is y. The constant term, there's none. There is no number that's by itself as a term. The number of terms is 2, right? So separated by that subtraction. This is a binomial. And the largest exponent there is 3. That's the degree. Okay, variables here, a. Constant term, 10, right? That's the number that's by itself as a single term. There are 3 terms here, and so this is a trinomial. And the largest exponent is 2. All right, let's try some harder ones. Here we have 2 variables, b and c. There is no constant term. There is no number by itself. There are 2 terms here, right? 1 and 2. This is a binomial. And the degree, that's what's a little bit tricky here. So we add the two exponents together. So technically the c has a power of 1 there. So we add those together. 2 plus 1 is 3. That's the largest exponent, or largest sum of exponents. All right. Next one, variables. There are none in this one. There is one constant term. There's just one term actually, so it's a monomial. And if there's no exponent at all, there's no variables, then the degree is 0. Okay, and last one here, we have variable is, there's 2, m and n, and there is a constant term, it's 4. There are 3 terms altogether, which makes it a trinomial. And the highest or largest exponent is 4 in a single term. All right. Let's move on to representing polynomials in different ways. So oftentimes we use like pictures or visuals to help us understand that the different types of terms we can have in a polynomial. So we use these smaller squares to represent 1 and -1. So if it's colored in this set of notes, it's going to be a +1, and if it's empty or not colored in, it's going to be -1. And then we have these x tiles, and then we have x squared, which will have like a length of x along each side. So the area of those would be x times x, or x squared. If you have real algebra tiles in your classroom, you will notice that if you try and line up the ones along, like if you try and put like a bunch of 1 tiles along an x tile, it doesn't work out to a perfect number. It's like that on purpose, so that the x truly represents like an unknown value. It doesn't represent like a certain value. Okay, so let's try and write down what these polynomials are. So here we have 1x squared. We can write a 1, but typically you don't. If there's just 1, we just write x squared. You can write the 1, it's not wrong. And then we have 2 negative x tiles. We have a negative x and a negative x, that would be 2 of them. And we have 3 1 tiles, so +3. All right, let's try the next one. Here we have 4 1 tiles, and then we have 2 negative x squared tiles, which would be -2x squared. So the coefficient in front of the x squared tells you like how many you have. Okay, and finally we're going to go backwards. Let's try and draw this. So we'd have 3 x tiles. They're positive, so we're going to color them in. And then we have 5, and because it's negative, we're going to leave them open. 5 -1 tiles. Okay, last, we're going to represent or use some polynomials to understand, like make a connection between a real life scenario. Kate owns a business making and selling her pottery. The total profit she earns, I'm just going to highlight some key terms, can be calculated using the polynomial expression 45p minus 6m, where p, sorry that's a typo, it should say p, represents how many mugs have been purchased and how many mugs have been purchased. So p is how many have been purchased, and m is how many she's made. Okay, so how much would Karen earn if she made 12 mugs and sold 9? Okay, so how many have been purchased? That would be p equals 9, and she's made 12. So let's use our expression here, 45p minus 6m. We're going to replace the p and the m with the 2 numbers that were given there. So 45 times 9 minus 6 times 12. So I've taken these values that are now known. They used to be unknown values. Now we're given actual values to replace them with. And 45 times 9 is 405. 6 times 12 6 times 12 is 72. And that would give us a total of, just want to use my calculator to make sure I don't get it wrong, 333. Okay. The cost of materials is rising, and Kate estimates she is spending $3 more per mug than she used to. Adjust the original expression to account for this. So that would affect how much money we're subtracting off, because now it's going to cost her more money to make the mugs. So instead of 6M, it's going to be 9M. So we're going to increase this coefficient by 3. So polynomials can be used to represent different scenarios in real life when you have some unknown values or some values that are changing. All right, so that is the end of the introduction to polynomials lesson.